My dear students, welcome to my YouTube channel. My name is Taramani S, Assistant Professor, Department of Commerce, GFGC, Pune, Bangalore. This class, let us learn the topic skewness. This is a chapter in the subject that is QABD, which is prescribed for BCom second semester of Bangalore University. Let us first understand what is skewness. It means lack of symmetry, and if a distribution is asymmetrical, it is called skewed distribution. And the definition given by Croxton and Cowden tells the same thing. When a series is not symmetrical, it is said to be asymmetrical or skewed. That means in an asymmetrical or skewed distribution, mean, median and mode, the values will not be the same thing, and it will not be having a bell-shaped curve. Those things we'll learn it in the next topic, like how to find the tests of skewness, how to find that skewness is present in a particular distribution. See, to say that a particular distribution is having skewness, the following four conditions are to be satisfied. The first one, it says in a particular statistical distribution, mean, median and mode will not be the same thing. They will be totally different. And when it is being plotted on a graph, the frequency distribution do not form a bell-shaped curve. In case it is a totally bell-shaped curve, mean, median and mode, they are the same thing, means it will not be having skewness. But here, in case mean, median and mode, they are not the same. And when it has not been forming like a bell-shaped curve, and one more thing is we have to find deviations, that is D, that is x minus median. Here it is x minus median. In that case, the total of deviations, positive deviations, and the total of negative deviations will not be the same thing. And the fourth and the last condition is the distance between Q1 and Q2 and Q2 and Q3 will not be the same. That means it will not be equidistant. And in case these four conditions are satisfied, it is said it is a skewed distribution. And in case these conditions are not satisfied, means it is a symmetrical distribution. Then the types of skewness. There are two kinds of skewness, positive and negative. Positive skewness means in that distribution, mean will be more than mode, that is x bar will be more than mode. In that case, it is being called as positive skewness. And negative skewness means when the value of mode is greater than the value of mean, that is z is more than x bar, it is called negative skewness. Here in this graph, you can see the types of skewness. The first one is showing positive skewness. That means the value of mean is more than the mode and median value lies in between. And the third graph, it shows negative skewness. That means here the value of mode is more than the value of mean and median lies in between. That is being called as negative skewness. And the graph in the middle shows a symmetrical distribution. It means it has a neatly bell-shaped balanced curve, and here the value of mean, median and mode, they are one and the same. To find skewness, we follow several methods, but in your syllabus you have Carl-Pearson's coefficient of skewness. How to find this skewness using this formula? Formula, it says SKP is equal to x bar minus z divided by standard deviation. K stands for Carl, P stands for Pearson. So Carl-Pearson's, and S stands for skewness, that is Carl-Pearson's coefficient of skewness, x bar minus z divided by standard deviation. And this is not at all new for you. We have already learned it long back. X bar stands for arithmetic mean, Z stands for mode, and sigma stands for standard deviation. That means to find out Karl Pearson's coefficient of skewness, you need to compute first X bar, then mode and standard deviation, and only after which you can find out the coefficient of skewness. But there is one thing, like in certain distributions, mode is ill-defined. In that case, we have to go for this empirical formula. So the empirical formula for calculating mode is equal to 3 median minus 2 mean. So, and in such a case, SKP, that is Karl Pearson's coefficient of skewness, we calculate it by means of the following formula, that is X bar minus Z divided by standard deviation is a basic formula we learned, and everything is written in the same manner, but only one change is there. In case of Z, that is mode, we have written the empirical formula, that is SKP is equal to X bar minus Z we had written earlier. So in that place, instead of Z, that is mode, we have to write the empirical formula, 3 median minus 2 mean, and once again divided by standard deviation, and simplify that, after which you will come with the formula like say SKP is equal to 3 into X bar minus median divided by standard deviation. And the result of this Karl Pearson's coefficient of skewness, Karl Pearson's coefficient of skewness normally would lie between plus or minus 1, but theoretically the value varies between plus or minus 3. So this is the theory part of skewness. In the next part, let us learn solving problems under all the 3 series. Thank you.